Let's go ahead and do a problem together as an example. And we'll do one in MyOpenMath so we get a feel for it. You draw one king from a well-shuffled standard deck of 52 cards. Let R be the event of drawing a red card, and let K be the event of drawing a king. We want to find all of the following, okay? So we have lots of things to find here. Let's do it in order. Let's start with N of S. So what does that mean again? Remember the N in front means number of, and S is sample space. So we want the total number of outcomes in the whole sample space. What's the total number of outcomes altogether? Well, it's a 52 card deck, and we're drawing a card, so there are 52 ways total to draw a card from the deck. Okay? So that one is pretty straightforward. So let's go to the next one. Okay? Now we want N of R, the number of ways we could draw a red card from the deck. Okay? So how do we calculate that? Well, it helps if we actually have the deck in front of us. We want to find N of R. And here are the red cards right here. And you could either count them directly, right? Or you can just know that there are two suits here, and each suit has 13 cards. So 2 times 13 would be 26 cards. So there's 26 cards that are red. So the number of ways that we could draw a red card, 26. Okay? There are 26 ways that we could draw a red card. Any one of those 26 cards would satisfy this event. Okay? 26. Let's calculate the probability of drawing a red card. Okay? Now, drawing cards from deck, in that case, each outcome is equally likely. There's not one card that's more likely to happen than another, right? If you've shuffled the deck well, each card has the same chance of being drawn. So the probability of drawing a red card, we calculate, use our formula, the total number of cards that are red, divided by the total number of cards in the sample space. Now we've already done the hard work for this. We've calculated this, and we've calculated this. The number of red cards, that's 26. The total number of cards in the deck, that was 52, remember? So 26 over 52, and if we put that into our calculator, 26 divided by 52, we get 0.5, okay? 0.5. And that makes sense, right? Just looking at this, if we circle those red cards again, that looks like half the cards in the deck. Okay, so there's the probability of drawing a red card is 0.5, meaning there's a 50% chance that the card we draw from a well-shuffled deck is a red card. Okay? Let's look at the other one. NK. NK is the number of ways we could draw a king. Okay? So again, we look at the deck and we just have to count them up. Okay, nothing fancy going on here. We're just counting. Here's the kings over here. And they're pretty easy to count. There's 1, 2, 3, 4 kings all together. Okay, and that's it. The number of kings is 4. There are 4 outcomes that result in us getting a king. Okay, there are 4 ways to draw a king from the deck. So now that we have that as 4, let's calculate the probability of drawing a king. Okay? Probability of drawing a king. Okay? So we use our formula. N of K, number of kings there are, divided by N of S, total number of outcomes in the sample space. There are 4 kings in the deck out of 52 cards total to choose from. And so if we throw that into our calculator, 4 out of 52, we get this number, 0.0769238. So 0.0769238, if I wrote that right. which is about like 7.7% if we were to think about it as a princess. So less than 10%. So there's a less than 10% chance that the card we draw is a king. That makes sense if we look at this, right? If we look at the kings, most of the cards are not kings. Those kings only make up a very small portion of the whole deck. And so we would expect the probability of drawing a king to be fairly small. Submit, and we have it right.